Hello everyone, welcome to my channel. So today's our LeetCode daily challenge problem is delete nodes and return forest. Okay, so what does this problem state? We are given a binary tree, right? And we are given some uh, nodes, right? Like we are given a to delete vector which contains some values, and we have to delete these particular values from this particular tree, right? So what whenever we delete some node from this particular vector, we get some extra subtrees because 3 is deleted, right? For example, we have to delete 3 from this particular subtree from this binary tree. If we delete 3, we get 6 and 7, right? So now basically from this particular one binary tree, we have got after deleting this 3, we have got 3 binary trees, right? 6, 7, and 1. So what we have to do after deleting this particular tree, whenever I get some extra, whenever it contains subtrees, I have to push these subtrees into our new vector, right? And at the end, whatever these subtrees we get, we have to push it into that particular vector and we have to return it. That's all the question states, right? For example, here, if I delete, we have to delete 3 and 5. So whenever I delete 5, we have to nothing. So 5 is deleted. So our new tree will look like 1, 2, 3, 4, 6, 7. All right. And whenever after that, I will delete 5. Okay. I will delete 3, right? So whenever I will delete 3, right, our vector will what our binary will look like 1, 2, 4, and then our two new binary will form, that is 6 and 7. All right, so this would be our answer: 1, 2, 1, 2, null and 4. Okay, and then only 6 and 7, 3 and 5 are deleted. Hope you have got this the question. Coming to the solution, what we will do, see, uh, for your better understanding, what we will do is we will traverse through this binary tree in any order, like pre, post, any order, and I will mark all the values that are present in this to delete vector with -1. So, for example, it contains 5, I will mark 5 with -1. It contains 3, so I will mark this 3 with -1 for your better understanding. So, right. So what our new binary tree will look like after doing such thing, this is our step one, right? So 1, 2, -1, 4, -1, 6, 7, right? So now what I will do is I will simply traverse through this tree in the post order traversal. I will tell you why I am doing this post order traversal because I will do this post order traversal, and whenever I receive -1 value, I will delete it and return null. Okay, and if this particular value contains left or right, then I will push it into our vector, right? And then I will delete it. So why I am doing the post order traversal? Because post order traversal simply means left, left, and then right. Okay, so left, left, and then left. So we will reach to 4. Okay, now we will check whether it contains -1 or not. No. So we will move to where? Right. We will not move to, because left, right, and then we will move to root. So I will move here. It contains -1. Yes. So I will simply delete it. Right. And then I will move to root. So basically, before moving to this root, I have get rid of this particular subtree, left subtree, and this particular right subtree. All right. That's why I am using post order traversal. So we have got this rid of this -1. So whatever new tree will look like 1, 2, 3, -1, 6, 7. Okay. And now where are we? Where is our root pointing to? We are pointing to this particular two, right? And after that, where I will move? I will not move to 1 because left, right, and then root. So I will move here, right? Then where I will move? I will move to the left, right? As left do not contain -1, so I will move to its right, 7. It does not contain -1, so I will move to this particular root. Then I will reach here. All right, -1. Now what I will do, I will check whether the value is equal to -1. Yep. Then what we have to do, I will simply push our vector is empty now at this moment. I will push 6 into our vector, roots left, because it contains left, right? If it contains right, yes. So I will push this 7 into our vector. All right. And then what I will do, I will return minus null value from here. Okay. So after doing so, after returning null, we get 6 and we have 6 and 7 node into our vector, and our new tree will look like this. And currently we are pointing to this particular root. Okay. Now, basically we have traversed all the tree, and at the end, what I will do, because I will check our root because we have solved the left and right. Now I'm in the root. I will check whether it's -1 or not. No, it's not -1. So what I will do, I will push it into the vector 1. Okay. So whatever is our answer, 6, 7, 1, 2, null, and 4. Hope you have got this problem, right? So basically we have to do nothing. We have to first, for your better understanding, I have marked all the values that we have to delete with -1. Then I have used post order traversal, right? While doing post order traversal, whenever I see -1, I simply first check whether it contains left or right. If it contains, then I will push into our vector. Otherwise, I will simply return null and delete. So this particular subtree get deleted. All right, that's all. So what does our code look like? See, first of all, for solving it, what I have done is I have make one unordered set, right? Because we have to check whether our tree contains the value that is into the delete vector or not. So we will simply use s dot find function for doing it, right? So otherwise we have to add it through this vector. So it will become it will increase the size of the code. That's all, right? So what I will insert all the values of delete vector into this s. I will call recur function. What I will do in recur function, nothing. I will simply traverse through all the values, and whenever I see that s dot find, like set is containing roots value, then I will make roots value is equal to -1. That's all. I am using pre-order traversal here, okay, for marking root value is equal to -1. All right. So I will reach here 1. I will check whether it is equal to 3 or 5. No. So I will move to 2, like whether 2 contains in the set. No, set contains 3 and 5, so I will move here. I will move here, right? 5 contains in the set, so I will simply mark it with -1. 3 is there in the set, so I will mark it with -1. 6 and 7 will remain the same. All right, so our whatever our new tree will look like this, right? Then what I have to do, I have to simply do the post traversal. So right, for that, first I have make one vector which we will return, which is of tree node type, because we have to store nodes into this vector, right? And then I will simply call post order traversal. So this is our post order traversal. If root is equal to null, then we will simply return root. Otherwise, we will move to left first, then right first. Okay. And whenever I find root value is equal to -1, I will simply check whether this root's left is present or not. That is, its root's left is not null or not. If it is not null, I will push root left into our vector, right? I will check its right, whether it is null or not. If it is not null, then we will push right onto it, right? Otherwise, what we will do, we will return simply null, because otherwise, sorry, like we have pushed left and right, so three is basically now -1. So I've pushed 6 and 7 into it, and now I will return null to it, so that these particular we get rid of this particular subtree. All right, that's all. Otherwise, what we have to do, if our value is not equal to -1, then we'll simply return the same value, that is root, right? For example, if I am here, 2 is not equal to -1, then I will simply return 2 to it. Okay, that's all. And at the end, what we have to do, see, we are here currently here, right? We have solved the left subtree and right subtree, but we haven't solved one a yet. So basically I will check if root val is not equal to -1, right? Because it is not equal to -1, because it is not equal to 3 and 5. So what I will do, I will push this particular root also in this vector, and then I will return the vector, right? So basically earlier we were having 6 and 7 into our vector. After that, one we have got the final tree this, right? After removing all the -1 values, right? So one is also remaining, so I will push at the end, I will push one into it. So right now I will run the code. Yep, it is doing fine if I submit it. Yep, it is doing fine. So hope you have got this problem. So if you like this video, please like and subscribe. Thank you. See you in the next video.